In this activity, students use satellite models and light sources to demonstrate planetary rotation and revolution. Students then role-play planets revolving around the Sun and realize that the farther away a planet is from the Sun, the larger its orbit and the longer its year. You'll need the following materials from the kit: Activity Sheet 9, 110-watt bulbs, light sources, meter sticks, roll of string, and a roll of masking tape. You'll also need to provide satellite models from Activity 2, scissors, and the names of the planets from Activity 1. At that point, beginning with the scaled distance to the closest planet, have students use meter sticks and scissors to measure and cut lengths of string to the longest scaled distances on Figure 9.3 the schoolyard will accommodate. Tie one end of all of the strings together for the Sun to hold over his or her head, and give the other end of each string to a student planet to hold. Then align students so that they stand in a straight line out from the Sun. Finally, have the planets walk at equal paces around the Sun, staying in their orbits. To begin Session 1, show students the demonstration satellite model. Then define axis for students as an imaginary line through the center of a planet. Ask students to imagine the foam ball is a planet and the plastic tube is its axis. Explain that in addition to orbiting the Sun, planets also rotate about their axes. Inform students that to rotate means to spin or to turn around, and that a rotation is one complete turn of a planet as it spins about its axis. Demonstrate the rotation of a planet by turning the tube to make the foam ball turn around once. Ask students, how would you define a day? Students will probably respond that a day is 24 hours long. Guide students to understand that a day is the time it takes for any planet to make one complete rotation about its axis, and that a day on Earth is 24 hours because this is how long it takes Earth to make one rotation about its axis. Then ask students, how would you define a year? Students should say that a year is 365 days or 12 months long. Explain that a year is the time it takes a planet to travel once around the Sun, and that the Earth rotates about 365 times as it makes one orbit. Therefore, an Earth year is about 365 days long. Next, describe for the class how planets revolve or travel around the Sun in their orbits. Define the term revolution for students as one complete trip of a planet around the Sun. Hold up the satellite model again and tell students that in this activity, they'll modify their satellite models from Activity 2 to construct a planet model to simulate a day and a year. Distribute a copy of Activity Sheet 9 to each student and give each team a satellite model and a pair of scissors. Ask students to complete questions 1 and 2 and help them disassemble their models. Then, instruct students to simulate days by spinning their models like tops. Ask students, what do the tube and the ball in the model represent? Students should assert that the tube and ball represent Earth's axis and Earth, respectively. Inform students that while all planets rotate at different speeds, and that one complete rotation of any planet is called a day, no matter how long it takes to make that rotation. Next, have teams gather around one of the two light sources and tell them that the light bulb represents the Sun. Ask students, does the Sun move around the Earth? Students should respond that Earth moves around the Sun, and not vice versa. Guide students to realize that it is Earth's rotation about its axis that makes the Sun appear to move around the Earth. Next, have students complete their activity sheets by simulating a planet's rotation and revolution around the Sun. When all students have finished, ask students which revolution took a longer period of time, the revolution with the model held close to the light, or the revolution with the model held farther away from the light. Students should have observed that the farther the model was from the light source, the longer it took to complete one revolution. To conclude Session 1, ask students, based on your observations, which planet would you say has the longest year? Students should respond that the dwarf planet Pluto has the longest year because it is farthest from the Sun. To prepare for Session 2, assign the roles of the Sun and planets to 9 students. Make sure to conduct Session 2 at a time when the class can visit a large open area of the schoolyard. To mark and measure the distances in the schoolyard, students will bring copies of Figure 9.3, meter sticks, a string, and scissors outside with them. To begin Session 2, inform students that they will model the solar system outdoors on a scale of 1 meter to 90 million kilometers, instead of 1 centimeter to 9 million kilometers. Distribute the materials to the class before you go outside, and then have the students who will play the sun and the planets identify themselves with the labels from Activity 1. Once outside, choose a central point and have the student's sun stand still at that point. Beginning with the scaled distance to the closest planet, have students use meter sticks and scissors to measure and cut lengths of string to the longest scaled distances on Figure 9.3 the schoolyard will accommodate. Tie one end of all of the strings together for the sun to hold over his or her head, and give the other end of each string to a student planet to hold. Then align students so that they stand in a straight line out from the sun. Finally, have the planets walk at equal paces around the sun, staying in their orbits. After the students have completed the role play, stimulate a discussion by asking, why is the length of a year on a planet far away from the sun longer than the length of a year on a planet closer to the sun? Encourage answers that use the terms revolve and revolution. Students should understand that the further away a planet is from the sun, the greater distance it must travel in one revolution. Explain to the class that each planet travels in its orbit at a different speed, and that some planets travel faster than others. Help students realize that though some planets revolve faster than others, the outer planets take longer to complete their orbits because they are at greater distances from the sun. To conclude the activity, remove and discard the tape from the planet labels and return all other materials to the kit. For science background, reinforcement activities, curriculum connections, and information about the Delta Science Reader, please consult your DSM Teacher's Guide.